No Fluff Just Stuff has been the gold standard for continuing professional education for software engineers. We pride ourselves on showcasing the best presenters in the industry, passionate, engaging, and informative. Our live conferences have served close to 100,000 attendees. We're now bringing our world-class training online. These half-day and full-day workshops are immersive, hands-on, and instructor-led. Our state-of-the-art classroom creates an interactive learning experience for all.
Other than a book or a video, the thing I love so much about these trainings is it's like having me on a Zoom call with you. We can actually ask questions and interact to actually get your questions answered.
Register now and master a new skill, or until May 31st, take advantage of our team subscription offer and get No Fluff Just Stuff quality training all year long. Hello, folks. Welcome. My name is Michael Carducci, and I'd like to welcome you to the latest in the No Fluff Just Stuff community virtual webinar series. And this week, we're going to be diving into a particularly interesting topic in the infrastructure Kubernetes ecosystem. We're going to be talking particularly about consumer-driven contracts. And it's at this point, I'd love to welcome our speaker, Jonathan Johnson, to the stream. John, if you're there, go ahead and join us and say hello to all the fine folks out there. Otherwise, it's going to be just me, and I don't have an awful lot to say on this particular topic. Yeah. All right. He's joining on now. Oh, looking very sharp there, by the way, as well in the No Fluff studio. I was in danger of needing to go to my emergency series of jokes, which nobody wants to hear.
Oh God, don't do that.
Yeah. There's a what is it? A query walks into a bar, selects two tables, and says, "Do you mind if I join you?" It only goes downhill from there. Jonathan Johnson, welcome.
Well, thank you very much, Michael. It's a pleasure to be here, and this is an exciting talk. I love to talk about this one. This is a revamped talk. I've been talking about consumer-driven contracts for maybe about 3 years now, but I recently redid it and modernized it a little bit. So as you know, software's changing all the time, so it's always good to refresh our material, and lots to give you today. So thank you.
Well, and you know I'm always all about fame and fortune. And before we kick off, just one thing I want to lead with, folks, that if this is a topic that interests you, if this is an area that you really want to grow your skill set, this is a great place to be. Jonathan is a very experienced hands-on practitioner as well as an instructor and passionate speaker. And we're going to be diving deeper into these topics on the No Fluff Just Stuff virtual workshop series. We're doing about 15 or 20 of these every month. These are live, instructor-led, half-day and full-day workshops, and you can access them a la carte, or you can sign up for the annual subscription that can even be shared with your team. So it's an all-you-can-eat type of package, all you can consume, and when you've had too much, give it to your team, let them dive into it, and we rotate out a lot of the content as well.
Yep.
And the second thing is, Jonathan, surely you're speaking at some of the No Fluff tour shows this year as well.
I am throughout the 2020 season into 2021. We'll be doing a lot of webinars, as well as the RConf that's coming up in
December.
In December, and my material is around the cloud native ecosystem, microservices, containers. Many of my topics complement many of other speakers, and we overlap a lot of topics related to this. So yes, I'll be doing a lot, and it's a very rich ecosystem, so I'm always adding more topics as we're moving along. And things are changing in the industry. Things are getting a little bit more mature. So it's always a challenge for me to take material and work on them, and then the next year, there's new twists and new angles to look at the topic and to improve it and go to the next level.
Right on. Well, you can find out all about that at nofluffjuststuff.com. I'll throw a link up. But that's enough from me. Why don't I hand it over to you and let's dive right in. And once again, folks, thank you for taking the time to join us this morning or this afternoon or evening or whatever time it is, wherever in the world you are. So I'm going to drop off and give it to you.
All right, Michael. Thank you very much. I put a survey up here, and let's see if we can just get a couple of responses to this. I just want to know from the crowd here, what's your level of experience with consumer-driven contracts? And if you can put some votes in, looks like some people are putting some votes in. We'll do this for about, I don't know, 30 seconds and see if we can get some votes here. I'm just looking for a survey of, yeah, I really don't know anything about consumer-driven contracts, or I use it all the time, or I'm somewhere in between. And most of the responses that are coming in right now, most are I'm not familiar with CDC at all. So, and normally I do this talk in about 90 minutes. So this is a condensed talk. I'm going to take it down to about 45 minutes or so and leave it open for questions. So I'll show you a couple slides and give you an introduction to it. And then we're going to do actually a hands-on scenario where we're going to walk through the concepts. I'm going to show you live in code how consumer-driven contracts works. It's a form of testing. Yes, sir.
Go ahead and when you're ready, publish. Don't forget to publish the results of the survey as well.
Right. So it looks like everybody's voted. So there is your sharing the results. You should be able to see them on screen now. Is that correct? All right. So it's interesting. Most people don't know about it. Some people are familiar with it, but really haven't used it. And there's just a smattering of people that use it either all the time. I think just one person uses it all the time. And that's very typical in our industry, is that a lot of people don't know about consumer-driven contracts, which is why I want to get these points across to you. So I have so let me take you through just a couple slides. I don't have all of the slides. I uploaded the slide deck to this Click Meeting webinar, so you can download the slides. But I'm just going to show a few of them just to get you into what consumer-driven contracts is all about. So let me switch over to that. Consumer-driven contracts can be it came onto my radar through the technology radar, and also reading Sam Newman's book, Building Microservices. And it's part of the maturity model related to building microservices. And it's a form of testing for microservices, let's put it that way. And your ThoughtWorks says it nicely in terms of consumer-driven contracts are an essential part of the maturity model for developing microservices and then putting them in containers. And what I talk about is cloud native and a lot of things related to Kubernetes. I'm very keen on this type of testing because it's related to microservices and running in containers and then putting them all on Kubernetes. So the idea behind it is, and I'm going to cut to the chase here. The idea behind it is you want to be doing all of your testing. Most testing is done from a developer standpoint. In other words, I write a class and I write a unit test and do the unit testing on it. I write a service and I do integration testing or API testing against that service. Or I write a series of containers that work together and I write some integration testing against it. But as a developer, all of the testing is centric to you. You, the developer, you, the designer of the system. What consumer-driven contracts is all about is taking the perspective of testing and testing requirements over to the consumer side. So you, being the person writing the microservice or service, is the producer of that service. The consumers, that's another term that's used in consumer-driven contracts. The consumers are the clients that are calling your service. Now, wouldn't it be wonderful to get all of their testing code, all of their testing contracts from all the different clients, gather all those contracts, and then run them against your code? Because if you just do all of your testing related to your service, you're going to be writing tests that it's almost like the fox is guarding the hen house. You're going to be writing tests against your own code. So therefore, you're going to know what you need to test, but you're not in the perspective of a consumer in terms of how would I actually use this service. You ever write a service or an API and then get the API all perfect and neat and clean? or a public method in a class. And then suddenly when somebody calls it, they pass in data that you would never expect. So consumer-driven contracts are about capturing all of that data that is being sent to you that you would never expect, that perspective. So it's a consumer-driven contract is about changing the perspective to the consumer side rather than testing only on the producer side. It's not a substitution. It's simply another tool in your toolbox to do testing. So let me dive a little bit into, so I'm skipping over a bunch of slides in this deck, but let me drive right into the Pact testing. The idea behind it is probably shown best in this diagram. And there's other diagrams I can show you in a minute, but let me just start with this. On the left-hand side, we have the consumers. And what happens is the consumers, multiple of them, not just one consumer, the consumers on the left-hand side, when they're making API calls, instead of making API calls to your service, they make API calls to a mock service. And when that mock service, when those tests are running, the HTTP requests and the HTTP responses are being captured. It's kind of like a wiretap or a wire mock. The idea is to capture that conversation. And then once you have a conversation with all these different consumers, those conversations can actually be captured into a document. And the framework that I'm going to show you in the Pac framework, it's called a contract, or a Pact, P-A-C-T. And they're actually stored as JSON in the physical sense. And they get stored into a library called a Pact broker. And then on the producer side, at any time, the developers of the producer can pull those conversations down and run them against the real service. And hopefully things pass. But sometimes they fail. And the failures are when your service is not behaving like the client behaves. So normally the producer would just be writing integration tests, some kind of tests on the integration side, testing the API. And everything's going to pass. And if it doesn't, they fix the code. The producers fix the code locally. The key thing is you're getting the perspective of the outside world. Now, do the consumers also have to write all the mocks? No, the Pact testing framework actually helps you define it in a very nice language. And the mocks themselves, based upon the language, are self-written. You can customize the mocks yourself, but a lot of the framework it makes it easier for you to approach the idea of defining that conversation and then having a mock being stood up to run that conversation against it. And we're going to do that live on a Katacoda experience. So I use this system called Katacoda for demonstrating a lot of live demos. And so we're going to go through a live demo that takes us through the event of writing a consumer and also publishing the producer, running them all on Kubernetes, and hopefully we'll get all that done within the hour. So that's a quick diagram for you. The key thing is that there's a wall between the producer and the consumer, and that wall is the Pac broker. It's simply a library of all the contracts. All right. So so ThoughtWorks says, don't get too wrapped. I like what ThoughtWorks says. They say, a lot of people get wrapped up around the tool, and we're going to be talking about a popular tool called Pact. But it's really more of a philosophy. Consumer-driven contracts is about embracing your consumers and your clients and looking at all those different perspectives. We're all, as humans, we're coming from a wide spectrum of backgrounds. And as there is lots of different perspectives. And when other microservices call your service, they're all coming from different perspectives, especially if your service is public and you produce a public API and you have a wider audience. The more you can gather all those conversations from the public, the more you can do better testing against your producer side. So don't get always too wrapped around it. The key thing is you're embracing the philosophy. Now, if you're familiar with Spring, they have something inside there called Spring Cloud Contract, which is a full-on implementation of consumer-driven contracts. So that's a very popular one. but it's Spring and Spring only, and it's in the Spring microservice system. And the thing about microservices and containers in Kubernetes is that it's polyglot. You can put lots of different languages inside of containers. So the Spring Cloud contract is something myopic toward just Java or the Java ecosystem. So really what we want is a cloud framework or a consumer-driven contract testing framework that's wider. So Postman is another one that has this thing called the Newman CLI collection. That's another way to do type of consumer-driven contracts. But really the elephant is the Pact.io framework from Dias. It was originally from Dias, and there's a whole history there. But it's been around for quite a while, I think 2015. And then 2018, Pivotal announced a full working relationship with Pact.io. So if you're doing Spring Cloud Contract, it works with the Pact project as well. So I would highly recommend Pact because it is very polyglot, and it's the best tool out there right now to do something with. There used to be another one from ThoughtWorks called Pacto, but it's no longer around. All right, so I don't want to get too far into Jonathan Potzel, but I want to just get into some terminology here. Consumers, producers, and we have this specification in between. They'll call the Pact specification. It's in a JSON document, and it comes in, and the Pac Foundation also supports lots of different languages, and Maven, Gradle, languages as well as frameworks. So Python or Node.js has lots of different support for languages. And of course, there's this broker that will hold the contracts in between. The Pact record itself is a JSON document that looks like this. You don't have to write this document. This document is self-generated. What you're doing is you're writing natural flow language, type of language on the consumer side. And that is when you run the mock tests with your testing tests, they generate these contracts. So I'm going to show you that live as well. And that's why I'm going a little bit fast here, because I want to show you all this working live. So there's a Pact broker that gives you a nice UI. When we run that on the Kubernetes cluster, you'll see that UI, and we're going to be publishing a few contracts to that registry. We'll see what they look like. All right. So that's a quick overview of Pact. But let me dive. So there is a foundation called the Pac Foundation. I think I can go to it for you. I would highly recommend you, after this, just reviewing, let's see if I can get that on the screen for you. Reviewing Pact.io. And if you want to know about how it works, I think if you go under documentation, I'm looking for the animation, getting started. And they have a nice introduction that will take you through how it works. But again, I'm not going to get too far into it, but I wanted to show you a quick animation. This is the classic consumer provider diagram where you have a consumer and it's calling against the live provider and you're doing testing. There's another type of, the next level of testing is putting a divider in between those two. So you have a mock, and then the mock, then you substitute the mock out for the live one. What consumer-driven contracts is about is not just having the mock, but capturing that conversation, putting the mock into a broker, into a Pac broker as a contract, and then running those contracts against a provider. And these are asynchronous. So everything that's going on the consumer side is done independently of everything that's being tested on the producer side. Right? And the communication between the two sides is the library. So it's just another way of looking at it. The Pac Foundation and the Pact.io have very good documentation and describing it in this manner. And I just wanted to quickly show that to you so you can take a look at it. But what I wanted to show you is a live Kubernetes session of consumer-driven contracts. And it's going to take a little while to get through everything because it's actually a full build of a small application. And if you go, here are all my Kata courses on various topics. And the one for consumer-driven contracts, I happen to put it under Kubernetes pipelines, because consumer-driven contracts is part of your mature pipeline, your CI/CD system. So it's another testing system that should be part of your pipeline. So I put it down here as consumer-driven contracts with Kubernetes. Okay. And you can run this by yourself, by the way, and it's all free. So if you go to this URL up top, you can see what, you can experience the exact same thing I'm experiencing right now. So if you have to leave early, just go to this Kata and there's hopefully some self-explaining text in here. I'm going to skip over. I'm going to do the voiceover of a lot of what the text says in the README. But you could do it on your own time and just read through the text, and it will also teach you a little bit about how to do consumer-driven contracts. Do you need Kubernetes to do consumer-driven contracts? Absolutely not. I just like to talk about the cloud-native ecosystem. If you're doing cloud-native, you're doing microservices, you're doing containers, you would naturally run this on Kubernetes. So I just wanted to have a working example of how that would look. So what I'm doing right now is I'm waiting for this Kata cluster to start up. And we do have a cluster now on the right-hand side. We have a bash terminal. It's just Linux. And we actually, it's not just Linux, but actually it's a small Kubernetes cluster with a master and a worker node. Now, if you don't know anything about Kubernetes, it's okay. I'm going to walk you through a lot of this. Some of the terms might be a little bit confusing for you and a little bit of magic, but hopefully this will make sense. I'm also available afterwards for questions, either at the end of this session or I'm available offline through various mediums. So please contact me if you have any questions and you want to know more about this. So here's our cluster. We have Helm installed. We actually have a Kubernetes dashboard that we can look at, what's running on our cluster. Right now, it's just basically a blank cluster. There's nothing there, and it's ready for us to start deploying applications. I could show you the Kubernetes dashboard, but that would start getting off topic. What I really want to do is really just dive right into consumer-driven contracts. So the first thing we want to do is we want to have a container registry. So we're going to be building a few containers. I'm going to show you an architectural diagram of what the application looks like in a moment. But I just want to let you know, we need to have a container registry so that when we build our containers, look privately, they can be held somewhere. So I'm just adding to this Kubernetes cluster a container registry. That's simply all I'm doing right now. And in a moment, it will be started. I'm running some commands right here.
Hey, Joe.
Yes, sir.
Your feed is cropped pretty badly.
I was wondering if that was me or.
Are you able to change your output resolution on the camera feed?
I don't
know. Or scale?
That is the weirdest thing. All right, I'm gonna have to take a look at that. Thank you. Thanks for alerting me that, Mike. Is that better?
Yeah. Let me drop off here so at least people can see. And you might want to keep that window size, but just do a zoom in the browser as well, if you can. If there's like a Control Plus or something.
You got it, sir. That's a good adjustment. All right. Sorry about that.
And then, Rajiv, to your question, there is a little control handle that will actually allow you to make the video feed piece bigger. I don't know if you can fully close the chat window, but you can certainly move. You can certainly shrink that section of the screen. In fact, I think if I do that, that'll happen automatically for you. So that's gonna put everything. Oh yeah, you can also dock it. It looks like. So that's a good thing to know as well. So I'll leave that there for a moment and let you get back to it. Sorry for the interruption.
No, that's a good thing. I didn't realize it was being clipped. I saw it being clipped here, but I thought it was a local thing, not on Click Meeting. So, okay. So we have a Kubernetes cluster and we actually have the registry that's available. See, it says available. And actually, if we do a curl against a registry, it'll show us that we have a list of repositories, and the list of repositories is simply empty. And we're going to do a little Kubernetes magic. I'm going to do a little port forwarding of 5,000 just so that we can access it. And we're going to add a little proxy so that we can, through the magic of Kubernetes, allow us to push and pull from the same registry. All right. So we now have a local registry that's up and running. All right. So the first thing I want to do related to consumer-driven contracts is, now here's a little thing about consumer-driven contracts. This is the same diagram. So this is just a step that talks about Pac. But I want to go on to get right to the source code. So I have some source code up on my GitHub account, and we're just going to clone that source code. And in it, there's a few projects. There's an H2 database, 2 microservices, and then I have the producer side, the consumer side for producing the contract, the packs. That whole source code has everything inside of it. And I'm going to show you an architectural diagram what that looks like. Here's the tree. So we're going to have an aggregator microservice, a cluster microservices, a COVID-19 microservice, and then we actually have I'm going to get into all the components, but we have a H2 world database, and there's a seeder that seeds the database with some population data. So the premise behind this application is there's COVID-19 data that's from the CDC and various other formats. The Johns Hopkins University has a GitHub account where there's a comma separated value spreadsheet that's being updated on a daily basis. So I'm pulling data from that. And I wanted to do a correlation between that and world population, so I can see percentage-wise, what are the infection rates throughout the world, not in total number of cases, but total number of cases per capita. So that's the idea behind this application. And of course, we want to have consumer-driven contracts to do all the testing for it. So we have a tree, and I have a table here that describes all of the components. Basically, I have 2 back-end components. COVID-19 is a data source, and I have an H2 database with world population as another data source. So we're going to start those 2 things up in Kubernetes. And then with the aggregator is something that delivers, it's kind of like the gateway API. So you hit the aggregator to query the combination of the 2 sets of data being pulled together. So you get the per capita infection rates. So there's a diagram right there for you. And what I'll do is I'll just, I want a different menu here. No, I wanted to show that just bring that up as this is Firefox. The Chrome has the open the image in another page, and I'm not seeing that here. Sorry, I'm just, let's see, copy image location. I think what I can do is just, all right, so there we have a reference to our architectural diagram for it. So there's our H2 world database. We have a microservices pulling it in. We have COVID data, and the aggregators pulling it. So these 4 boxes are our producer side. And then we have a consumer on the left-hand side that's running mock tests that would be mocking the aggregator. And then those mock tests, when it runs those tests, get submitted to the Pac broker. And then the producer side, when it does verification, will pull those packs using Pac Verify. Okay. So let's dive right into that. The first thing we want to do is add the Pac broker. The Pac broker is this right here, this component right here. And it's simply a library that holds the JSON artifacts. And there's a few instructions here that get it up and running. It runs as it comes as in a Docker container. So if it runs in a Docker container, we can put it in a Kubernetes pod and get that up and running on Kubernetes. And in a moment, it will be up and running. Right now, see it says container creating. So it's downloading the container from Docker Hub. It's a public container, and it's starting it up, and it'll be ready in a few moments. I'm not going to wait for it to start because what we want to do right now is quickly generate those On the consumer side, we want to generate the packs. So there is code in here in the Pac directory, in the source code that we cloned. There's in the Pac directory. There is a Node.js consumer with some test code inside of it. And unfortunately, we have to actually do npm install because it's Node.js, and we have to do so it has to download the internet for a moment. And then we're going to run the test. Now, the tests were already pre-written, but you can certainly dive into this code and you can see what the format for the testing framework is within Node.js for the consumers. And what it's going to be doing for us, we're going to run 2 tests. So npm run test consumer. Once this is done, it's done. So we're going to run test consumer. And what that does is it takes that consumer code, the tests, and it stands up the mock, runs a test against the mock, captures that conversation, and puts it in a JSON document. We're going to do it for two contracts, consumer A, consumer B. And if we look at those contracts, this is what they... Okay, that Shen line should be working, but we're just viewing it. I'm assuming that they did get built. It's just showing me, it's showing me an error right here. So there'll get a little demo guide action going on. All right, so it is there. That's the A. And that's the B. So they are there. I don't know why that. It looks like I have an error there because the C is missing a number. That's what's going on. My problem. My apologies. I'll fix that. You need something like C5. No, all right. I'm not going to worry about that. And we're going to get back to it. So we have 2 contracts that are available. So now what we want to do is publish those contracts to the broker. And we're simply going to provide on the client side, we're going to provide the client an access to where the broker is located. So it's just a REST service that we'll submit those. So there's a npm run publish pack. The Pac framework on the consumer side has an API for generating packs and publishing packs. So within the Node.js ecosystem, you can add the Node.js Pact APIs, and that will allow us to publish our packs. So now if we go to the UI for the Pac broker, we should see these 2 JSON documents in the Pac broker. And up here on the top side, I have this thing called Pac broker. And that will bring us to the service that's running on Kubernetes. That's the Pac broker registry. And it comes with an example app. But here's our consumer A and consumer B that we just generated less than a minute ago. And you can actually click on them and get a little bit of graphical eye candy about. So here's an aggregator, and the consumer A and consumer B are going against the aggregator. So that's our contract between two consumers talking to the aggregator. So now let's get a little more. Now that we have those contracts, the producer is going to want to run those contracts against the actual code. So we're going to go through a series of steps here that build the code and then publish them onto Kubernetes, and then we're going to run our verification. So let's try that. So the first thing we want to do, and this is kind of a lesson in terms of doing some interesting things with Kubernetes. How do you start a database in Kubernetes? Well, we're going to start by first creating a container that populates the H2 database with some SQL. And there's a side container, not a sidecar container, but there's a container that when a pod starts up, like an H2 database container, the init containers can do manipulation of the primary container. And in this case, what it's doing is it's seeding the database, the H2 database with population data. So as the pod comes up, the seed container runs and it does its work against the H2 database. So what we're doing right now is we're simply taking that raw code of the seeder and we're turning that into a container. We're going to build that container, publish it to the registry that's running on Kubernetes. And then we're going to go over and start our H2 database pod with the Cedar as the side init container. In a moment, that will start. So there's a lot of information I'm throwing at you here that you probably want to take some time afterwards and kind of dissect this whole project and kind of see how it all works and it's put together. It's not a lot of code, but what is a lot is that there's a lot of moving parts. You have to keep straight in your head. But this reference diagram of the architecture is a good way to say, okay, what am I working on right now? What am I looking at right now? So right now we're working on this H2 world database and getting this pod up and running. But before we can get that pod up and running, we need to have a contract, a Cedar. So that Cedar is right now. So in our repositories, we have a new container called H2 Cedar. So in the next step, we're going to start out H2 database. And in this YAML file, there is the definition of the H2 container plus the init container for the Cedar. I could show it to you, but we don't have a lot of time. It's just a YAML definition for Kubernetes. So right now, that container is being started. In fact, it's not only started, but it's running. There's our it's initializing init. And it will start in a minute. So that init is the Cedar is actually populating the H2 database. Once it's running, H2, the database actually has a nice UI built into it. So you can a little SQL Explorer. And once it's running, there it's running now, we can actually go to the database. We're going to need to connect to it. So if I go to the database and we put in the correct URL for it, no user and password, and we connect to it, we have a world database. And so if we say select star from city, we have our cities. So the Cedar had populated the H2 database with this data. So now we have part of the producer. We have one of the data elements for the producer. So the next part is, okay, now world population. So the next part we're working, so go back to our reference diagram. So the next thing, so we've done this world database. Now we're going to stand up this microservice that connects to the database. So go into that directory where the code is for the world microservice. This is written in Spring Boot. I have another talk on distilling Java in containers. So this doesn't do the whole distillation pattern and using things like GraalVM. So this container tends to be kind of heavy and fat, larger than it needs to be, but it works. That's the important part. So right now what it's doing is doing a Gradle Build, Gradle W build, and Gradle W with Spring Boot now has a nice new task called boot build image. And what build boot image does is not only build your jar file, but it takes your jar file and it puts in a container for you. And then right after we build it, we simply say Docker push, and we push it to our registry that's running on Kubernetes. I make it sound so easy, don't I? It's hard. Kubernetes is hard. Actually, I take that while it's building, I take that statement back. Kubernetes isn't that hard. It's distributed computing that's hard. And I do a whole talk on that. A lot of people get miffed and mystified by, sometimes how complex Kubernetes is. And I'd say don't blame the tool. Blame the fact that you're running all of your services distributed in lots of different repos with lots of different pipelines with lots of different deployment models that go to a distributed cluster. And how you have to keep all that straight in your head. That's what's hard. Kubernetes is simply a tool that's pulling that orchestration together for you, making it easier. All right, we're still waiting for the build. It's like watching grass grow, which is not fun. But when it gets done with this in a moment, what we're simply going to be doing is we're going to have a new container that's built. That's why it's taking so long. It's because it's building the container. And then we're going to push that to our local registry. And we're going to verify that it's in the registry. And then the next steps are okay, now that you have it in the registry, let's start those on Kubernetes, which will complete the diagram here, the world population. And it looks like it just finished. Oh, darn it. 2 minutes already. And there we go. Almost there. I could have all these containers built for you up front, but that would kind of take some of the fun out of like the working elements of how this is all put together. It's nice to start just from raw code. What I'm not doing is actually writing the code, which would actually take the most amount of time. What we're doing is we're just starting with pre-written code and then going from there. This is almost like the ops standpoint of your pipeline for doing consumer-driven contracts. And done. All right, so now we have built successfully a container. Let's push that container to our registry. And there's lots of layers here because it's a fairly fat container, not optimized to my liking, but it will work. So it's now pushed. So now if we do a catalog of the registry, we have our Cedar container in there, which is already run. And we have a world population microservice written in Spring Boot. And and then what we're going to do is we're going to deploy that. So we'll have a YAML file that deploys the world database, the world microservice to Kubernetes. And when it gets deployed, it has a URL to the H2 world database. So that microservice is now connected to the database once it's started. And it is not available yet, still container creating. And then what I'm going to do right after that, I'm going to do a little verification. I'm going to run some curl commands against the world population microservice just to verify that it's up and running and it's returning data. If it returns data, that tells us that it's actually connected to the H2 world database. So there's just a quick ping. The ping worked, so our microservice is working. Here's a query against the countries. And here's a query against the cities. So now we're getting, you remember I went into the H2 World Database SQL, I did select star from cities. So now I'm doing select star from cities and countries using REST calls using Spring Boot. That's all that is, okay? So those are two services are up and running on Kubernetes. The next part to do in our diagram is our COVID-19, and then the last one is the aggregator. Hopefully those builds will go a little bit faster. The first build is a little bit slow because it has to cache everything. Now that we have everything cached with Gradle, it should go a lot faster. So we're now in the COVID-19 directory. And if we do a boot build image of the COVID-19, it will, this is also written in Spring Boot, and it's gonna be a lot faster. I guarantee. Guarantee. And then we'll do the exact same thing. Build it, push it, and verify it's in the registry. And because it's using the same version of Java, some of the layers are already there. And see how that build is a lot faster. So, and the pushing it is a lot faster because those layers are already cached as well. So now in our registry, we have the COVID-19 microservice. And again, we can go against that URL and ping it. Phew, it worked. And there's our metrics. So now we're getting metrics from the COVID-19. This is the world data metric. This is the daily metrics. So for instance, if we went against, it's kind of interesting. We went against grep, 5 lines for India. So as of yesterday, there's 52,000 new cases of COVID-19 in India. But it's one of the countries that's taking off right now in terms of outbreak. So if we go to the next step, now we have these two data sources ready. Let's run the aggregator and see if we can aggregate those two data things together in a kind of like a gateway API. So we'll go to the aggregator, exact same thing. It's another Spring Boot applicate microservice. We're going to say boot image build. Again, it's going to be fairly fast because we've already built a container using Spring Boot. Everything's cached. All it has to do is build the jar, loads the jar into essentially inside of itself, inside of Gradle and this plugin for Gradle for Spring Boot. It defines the Docker file for you, puts in an opinionated Docker file with an opinionated container about what they feel the best stack is for Spring Boot, puts your executable jar file in there, exposes the right port, has the right entry point definition, and it's kind of nice. I used to have to use things like Jib from Google, or another one from Ben Mushko. He did a lot of Maven, and he did Gradle plugins to build containers on the fly. I used to use his, but now it's kind of nice. It's built as just a task inside of Spring Boot, as it should be. Things are getting easier in this ecosystem. More and more tools are being added. Almost done here. And once we do exact same thing, once we have the container built, we're going to push it to the registry. Should go fast. And voila, now we have the aggregator as a microservice in a registry. So what we're going to do, same thing. We're going to start it on Kubernetes. There's our pods starting up. It's started already. It's very fast to start because it's all cached. Those layers are all cached. So we can ping the aggregator, and it worked. We can get the list of countries with the aggregator, and now the world population is being merged in with the different cases throughout the world. So getting our per capita information, and you may see a problem in the data, and we'll get to that in a moment. But we're certainly getting our JSON results. So that was that last 10 minutes was getting through building up the producer. So now we're getting to the heart of it. Remember we did early on, we did the consumers and we built those packs, and those packs are now in our Pac registry right here, consumers. Now what we're going to do is we're going to pull those packs from the registry as a producer, and we're going to run those against our aggregator and make sure that our clients agree with our producer. And of course, for good demos, it shouldn't work the first time. There's something should be broke, something should break, because that's the biggest teaching moment here. So let's go into the aggregator directory, and in Gradle W, there's a task that gets added. There's a plugin for Gradle as well as for Maven for Pact, and you can run a task called Pact Verify. And what Pact Verify will do is it'll go to your Pact registry, pull down the contracts, and run those contracts against your running microservice, which is at another URL. So Pact Verify simply pulls down the contracts, sends them to the producer, which in this case is the aggregator, and verifies. What it does is it looks at the responses from our aggregator and compares those of the responses of the client side mock aggregator, and they better match. If they don't match, then there's a problem. And in fact, that's exactly what happened here. And that's why we have a build failure, is because something didn't match here. And in fact, let me show you exactly what didn't match, just to get cut to the chase. I'm showing you here what our producers was retrieving for their per capita cases. This is % cases per capita, and it's all returning 0. I know that in India, they have X amount of, was it 3 billion people? X number of people in India and X number of cases. So there should be some percentage greater than 0 here, and it's not. So we know there's a problem. So, and again, I'm going to cut right to the chase. Well, the Pact Verify is simply doing a regular expression to do comparisons. That gets fairly complex in terms of what you can do in terms of how tight you want those comparisons to be, or how loose, how lenient you want those comparisons to be. And that's the trickiness of any kind of testing, is that when you get a response from something, do you compare it exactly, or do you compare it generally to match a pattern? In this case, we want some number that's floating that's greater than 0 for all of the cities. We actually don't want anything greater than 0 for all of the cities, which is kind of a misstatement. We actually want all the cities and all the countries to be 0, but as we know, we have a problem with that right now. So what we're going to do is we're going to look at the problem is actually in the aggregator code. So we're going to go to the aggregator code. And let me just show you where the problem is. See, it's on line 67. We do this all the time in our code sometimes. We put in a little testing code, and maybe we'll put a to-do comment next to it, and we say, oh yeah, I'll take that out later before I do the merge or the check-in or the merge. And the developer in this case didn't do that. So he left the to-do in there, and he or she was just testing for divide by zero error, just making sure that everything's okay when there's divide by zero. Left that code in there. Not a good idea. And of course, there's better ways of doing that rather than actually putting that inside the code. But let's correct the code. So we're going to do a little Linux magic with sed, and we're going to just use sed to modify the code. And what I just did with those 3 lines is now line 67 was now taken out. So that population equals 0 has been removed from the code. There's our new code. So now let's build our code now that we have correction and run the Pac verify again. Now that we've corrected the code, we should get better data coming out of our microservice. Do a quick time check here. About 7 minutes left. So normally I do this in 90 minutes, and even that's kind of rushed. And so I'm giving you in the 60 seconds, maybe it's your lunchtime, just a quick overview of how CDC works. And again, go to pact.io to get a deeper understanding about how it works. And you can then once you understand that, come back to this Kata. It's free. There's no credit card or anything like that. Where you can run this again. And if you don't know Kubernetes, there's another layer that's making it a little more complex. But you may learn something about how to do Kubernetes as well, which I would love. So now that we have a new build, let's, the next step is we just built that container. Let's publish a new version. There's our semantic version of, we went from 001 to 002. Then we're going to tell Kubernetes, hey, there's a new, for your aggregator pod, there's a new container, please. So I just patched it. So now the old container went away and the new one just started about 11 seconds ago, the 11S. So now that we have a new container deployed to our cluster, we're going to run Pac verify. And sure enough, we should see build successful. And sure enough, that's what happened. So in our diagram, what just happened there is we made a change to the aggregator, republished a new aggregator in this pod, and then we ran Pac verify against the aggregator, and it pulled the packs from the Pac broker and ran them against the aggregator. And what this means, the fact that there's build successful, it means that you are now in agreement with your consumers. Your consumers created a whole bunch of, you may be writing still your integration tests locally to verify your API. But the other thing is what you're doing is you're adding to your toolbox this extra layer of testing that's getting to perspective of your clients. And now we're all happy dogs, okay? So that's a demonstration of consumer-driven contracts. My apologies for being so quick on it, but you can see how we went from a blank Kubernetes cluster to running multiple microservices on there with the Pac broker. We ran the Pac verify, we ran Pac produce, and then we ran Pac verify. So now I'm going to open myself up to questions in the remaining time we have. And I'm just seeing here, I see one here from Andrew Johnson. What if you were testing a service that didn't have pre-canned data to return? Oops, just scrolled away. Oh, thank you, Mike. Well done. Would a consumer write a test suite that first does whatever it needs to do be done? Yes, absolutely. You talk about behavior-based development, BDD, or behavior-based design, BDD. That's the whole idea behind it, is that because you now have a Pac broker in between the producer and the consumers, while it's waiting for the producer to produce the actual service, the consumers can start writing up how they believe, they can start writing tests about how they believe the service should actually work, which is a really helpful document. So now you have all these Pacs in the Pac broker. So that's a really helpful set of documents that the developer of the producer can start referencing. It's going, oh, I see in the design requirements that, this is how the API should work. But now that I look at the packs, I have an even better idea about how the conversation should work. And maybe those packs are wrong. Maybe the consumers are writing contracts that don't follow the requirements. And that's another. The key thing is that it's another ability for you to document exactly what that conversation should be between the producer and consumer. And every time you have a document, you have more opportunities for having a discussion when there's a disagreement between producers and consumers, which is really what you want. And you want to shift that left as early as possible. This is why it's part of your maturity model for microservices. So I hope that answers that question. Good. How confident can I be if I do not have CDC for microservices that are going to get deployed to production? It's a recommendation to use it. Do you have to do it? No, I'm sure there's thousands of microservices and containers are being produced, and those teams don't know anything about consumer-driven contracts. So it's not a requirement you have it. I'm just recommending it as it's another layer of protection for you to increase your ability to shift left your testing. I'll see if I can show you a slide in a second. If you want to know more about my thoughts on that, I would take a look at her in the slides. So let me turn off the other one. Hold on. Cindy Sridharan, my apologies. She's writing some good books. She writes some good blog articles. And I really like this. Sorry, it's a little clipped. I really like what she talks about it. So she talks about all these different types of testing. And look at this. One of them this is just one of them, contract-driven testing. So, these, if you're doing distributed computing, especially with Kubernetes microservices, these are all the types of tests that you should have in your toolbox. Do you have to use all of them? No, you don't. But it's recommended that you at least know about them. You've made conscious decisions to use them or not to use them on your team. The more you're using them, probably the higher your maturity model is. I might get back to another question. Good. How does this work for post-mutation type use cases? Post-mutation type. Oh, yes. Meaning if the producer changes their API, how confident are, that whack-a-mole problem, right? There's always that living fear whenever you change the code that you're going to break some consumer out there. And one of the nice things about now having these contracts is that you have visibility in how your consumers are consuming information from your service. So often what we do is we'll bump our API version. So hopefully your API version is also semantically versioned. So often when we make a change, we'll bump either the patch level or the minor level, or maybe the major level, but we'll patch one of those numbers to protect us. So if something breaks, you say, well, did you check the API version? Well, sometimes you want to make a change, and yes, you want to make a change. And let me come up with this. Let me have this scenario. So with semantic version, you should bump the patch number if it's a breaking change, and then bump the minor change if it's also a breaking change. Or sorry, no, you bump the patch number if it's just a minor change that's not breaking, but you bump the major minor the second number. Sorry, I'm getting confused here. If you bump the second number if it's a breaking change. So how do you know whether it's a breaking change or not? Well, you know inherently, but wouldn't it be nice to run some verified packs against your change to see if those verifications break? If they break, that's indicating to you that's probably a patch number change rather than just a minor number change rather than a patch number change. Oh, that was I confused that answer a little bit. Sorry about that.
I think I might have interpreted that question.
Any other questions?
Can you hear me?
Yes, I can.
I think I might have interpreted that question a little bit differently.
Oh, okay.
That it was more of a, what happens if my microservice is doing some kind of where there's not a single expected static answer. That if it's not deterministic, let me try that way. That if your microservice is not deterministic, how would you define consumer-driven contracts?
Yeah, and I kind of alluded to that in the beginning, somewhere in there where I was talking about the regular expressions. And this happens with any kind of testing anyways. When you write a test, sometimes when you change the back-end implementation, your test will fail, even though in your mind, it's actually still a valid response. It's just that your test is too restrictive. So what you have to do is you have to make sure that, that was my reference to Jonathan Postel, is that when you make a request, when you're doing your mocks on the client side, you should be very precise about the type of data that you pass to either the mock or the real service. But when you test the response, you should be very liberal in terms of interpreting that response. And when I say very liberal, then you get to the point of like, well, sometimes you can overdo getting too loose, and now you're not actually doing any really valid testing on it. And that's where the engineer mind comes in. We have to make those choices and those balances. The Pact framework has an API in place so that you can put in things like regular expressions to help you make those determinations about what is a pattern match and what's not a pattern match. And I say regular expressions, it doesn't have to be that, but it often tends to be a regular expression in the API.
Got a couple more questions here in the queue, and then we're probably got to wrap up for time. But the next one here is this.
Usually request responses form some sort of conversation. Yes. Multiple request responses, input to future requests, elicit responses. How does Pac handle? Right, because what I've been talking about so far is, so when you we're going to be making a call to the aggregator service, and the aggregator service obviously is making hops to two other services. And that's not what this question is about, but it kind of alludes to it. So what we're doing in this whole demonstration is simply testing one call. But what if you want to make one call against one service and you grab that data and then pass that data to another service down the chain in a sense of now you have a holistic transaction that goes on. For instance, a test suite that will create an account, add some data, some cash to the account, make some spending, and then watch the amount go down, and then you want to close the account, and maybe that's a test suite. So that would be a series of transactions put together. Fortunately, those would all be separate conversations, separate packs to every back end, but you'd still be using the exact same tools you have today to do that. So if you're using like a test suite, an NG, test NG, or JUnit, or Spock, or Cucumber, all of those frameworks you use today by using Pact, it doesn't mean you have to get rid of all of the existing frameworks you use today. It's still the exact same testing methodologies and clients. So you can still do test suites that require lots of different transactions. I think that's my first approach to doing it. You may want to dig in the documentation for Pact.io a little bit more, and they may have a way to bundle a whole transaction together inside of a single pack. But in my mind, that wouldn't make sense because on the producer side, it's the producer that just wants the consumption of that one conversation against their single producer. So again, I think I would more lean toward the test suite side at a larger level related to the existing applications you have today.
And we got one final question here before we got to wrap up, and this is from Jamie.
Hey, Jamie. How do you differentiate between contracts that are proposed, requested by consumers and the ones that have been committed by producers? So the producers actually don't commit any, assuming that's not a typo, the consumers never produce any contracts. They shouldn't. It's not their job to define the contracts. Their job is simply to accept the packs and make sure they work or not work. And then a conversation ensues if they don't work. So only the consumers are producing them. The consumers can, in the UI for the there is metadata inside of the packs in the JSON, and you can tag the metadata, meaning that, and you can tag it with like for testing only or proposal or drafting, so that the producer actually doesn't use it in the actual verification. So there are ways to filter out, even though packs are published into the registry, you can say, hey, well, there's a pack here, but don't actually start using it yet. And you can actually semantic version your packs as well in a registry. So again, producers never produce packs, they only consume. So yeah, it's confusing to overload those words. So producers will only use packs and reference them. And it's the consumers that are responsible for generating them and updating them. All right. All right, thanks, Mike. Again, you can contact me afterwards on lots of other questions and topics on this. Let's see if I can get to my contact data. I can't get to it. I don't know why. There we go. That's me. Email, Twitter account, GitHub, pull requests. You can do that too. LinkedIn. And I will be on various webinars throughout the No Fluff Just Stuff series in 2020 and 2021, continuing along the way. I have another one coming up at the end of September. Thank you, Michael, for putting it on the schedule. That is talking about Kubernetes concepts. So that's if you're confused about Kubernetes and how it works, the end of September, I'll be doing a webinar, 3-hour webinar on getting started with Kubernetes, which is really a prerequisite for this talk. So, all right. Thank you. So thanks, everybody. I really enjoyed it.
Yeah, thank you, Jonathan. Thank you, folks, for tuning in this morning. And there's a link right on the top of the screen here if you want to learn more. But really appreciate everybody coming out. And Jonathan, thank you for sharing your insights and expertise.
Enjoyed it thoroughly. Thank you, Michael.
All right. Thank you. Take care, folks.